Hey everyone, and welcome back. You know, we love to dive into the latest advancements in tech and material science here.
Absolutely.
And today's deep dive, well, let's just say it's got the potential to completely change how we think about our devices.
I think that's a great way to put it.
So we found this really interesting article on scitechdaily.com.
Oh, yeah, I saw that one too.
It's called Breakthrough Material Perfectly Absorbs All Electromagnetic Waves. And you know how sometimes you're like, why is my Wi-Fi so slow or my phone's like burning up in my hand?
All the time.
Well, researchers over in Korea think they might have found a way to fix those problems. And
A whole lot more than that, too.
yeah, actually like way more than that. So maybe we should start with like, what's the core problem this new material is trying to solve?
Okay, so it really comes down to electromagnetic interference.
Right.
And you know, all of our devices, phones, laptops, routers, everything,
Yeah.
they all emit these waves, electromagnetic waves.
Right.
And all those waves, they can actually interfere with each other. And that's what causes like all kinds of issues.
Okay.
Slow internet speeds, glitchy Bluetooth, even some more serious concerns about like how a device performs and even safety in some cases.
Oh, it's like an invisible traffic jam, but with like waves instead of cars.
Exactly, a perfect analogy.
So how do we usually deal with that kind of like electromagnetic traffic?
Well, traditionally, we've used electromagnetic shielding, but that's kind of like trying to redirect all that traffic with walls. It doesn't always work, and it can even backfire sometimes and make things worse.
So this new material is like a totally different approach.
Total different.
What's it doing differently?
It's absorbing those waves instead of reflecting them. It's this ultra-thin film developed by KIMS, and get this, it can absorb over 99% of electromagnetic waves across multiple frequencies.
Wow. 99%.
Yeah, so not just Wi-Fi, but 5G, 6G, even the radar used in like self-driving cars.
That's insane. That is way beyond just blocking a single band. So how do they get it to absorb so many different kinds of waves?
Okay, so they've kind of combined a few key elements really cleverly.
Okay.
First, they took this material called ferrite and modified it.
Great.
Yeah, you know, so they can target specific frequencies. It's kind of like tuning a radio to pick up a specific station.
Got it. So that's how they can get all the different types of waves.
Right, and then on top of that, they add these conductive patterns onto the surface of the film.
Interesting.
They're like these tiny little roads almost that guide the waves and control how they propagate. They're like directing them towards the absorbing material.
So they're not just blocking the waves, they're actually like manipulating them.
Yeah, exactly.
Wow, that's wild.
And then just to make sure that nothing gets through, they add a layer of carbon nanotubes.
Okay, I've heard of those. They're like super strong or something, right?
They're incredibly strong, and they have great shielding properties.
Hmm.
It's like having a super strong net that just catches any stray waves trying to sneak through.
And you said this film is ultra thin. Like, how thin are we talking about?
Thin enough that you could imagine it being used in flexible phones or wearable tech, like woven directly into clothing.
Wow.
Or even just like thin coatings applied directly to electronic components.
So this is actually a really practical material.
Yeah, and here's the thing. They've tested its durability too.
Oh, really?
They bent it over 5,000 times, and it still held its shape.
5,000 times.
Yeah, so, you know, it's not just some flimsy lab experiment. It can actually withstand some real-world use.
Wow, that's super impressive.
It definitely has the potential to be much more.
So what's next for this material?
Well, the researchers have filed patents, and they're working with companies to figure out how to use it commercially.
So this isn't just science fiction. This is like science about to hit the shelves.
Potentially, yeah. It's definitely still early stages.
Okay.
Then there are still some challenges to figure out,
Right.
But there's definitely a lot of interest from the tech world.
So before we start like daydreaming about having this in our next phone upgrade, let's get into what this would actually mean for us, like in practical terms.
Definitely.
We'll be back in just a minute to talk about just how this material could change the way we live and interact with technology.
Welcome back.
Okay, so let's get into some real-world applications for this material.
Yeah.
The article talked about a few things: 5G, 6G, autonomous driving, better performing devices. Like, what are we thinking here?
Let's start with the 5G, 6G thing.
Okay.
You know, everybody wants faster, more reliable internet.
Yeah.
Especially with 6G coming up, they rely on really high frequency waves, and those are more susceptible to interference.
Oh, right, yeah.
So imagine if this material acted like a noise canceling system.
For your internet connection.
Exactly.
That's wild.
It basically creates this cleaner pathway for data transmission.
So less lag.
Less lag, faster downloads, fewer dropped Zoom calls.
Okay, I'm sold.
Right, but it's not just about speed, though.
Okay.
Think about the Internet of Things, all those devices talking to each other wirelessly.
Right.
This material could help prevent them from creating like this huge electromagnetic mess.
So everything just runs smoother.
Exactly.
Okay, that makes sense.
What about autonomous driving?
Yeah, the article mentioned something about radar.
Yeah, so self-driving cars, they use radar to kind of see their surroundings.
Right.
But those radar signals can be disrupted by interference.
Oh, especially in cities, I bet.
Especially in cities, yeah, where you have lots of reflective surfaces.
Right.
But now imagine if you strategically place this material around those radar sensors, it creates a clearer picture for the car's system.
So less interference equals safer driving.
Exactly.
That's amazing.
And if we can make self-driving cars safer and more reliable, we can start using them more.
Yeah.
And that changes everything: personal transportation, shipping, logistics.
It's crazy to think something so tiny can impact something as big as a car.
Right. And think about all the other things that use radar, too.
Like what?
Weather forecasting, air traffic control.
Oh, yeah.
Anything that uses electromagnetic waves to sense or communicate, it's like giving them a clear channel to operate on.
Okay. That makes sense.
What about device performance?
Yeah, the article mentioned overheating.
Right. So heat in a device, it's often generated by resistance from the electrical currents.
Right.
And some of that is caused by electromagnetic interference within the device itself.
So it's not just about external interference, but also what's happening inside our phones and laptops.
Exactly. So by absorbing those stray waves inside the device, this material could lead to less resistance, less heat generation.
So a cooler, more efficient device.
Exactly. And a cooler device means a longer-lasting battery.
Oh, that's huge.
Less energy wasted fighting heat means more power for actual processing and functionality.
So it's like this material is the ultimate upgrade.
Yeah, it's not just for individual devices, it's for entire networks.
It's like creating a more peaceful electromagnetic environment.
A more harmonious environment for technology to thrive in. I like that.
Okay, so this all sounds incredible. But let's remember, this is still early research. The article mentioned that companies were interested, but it didn't say who.
Right. But the fact that they filed patents in multiple countries and they're looking for commercial partners, that tells me they really believe in this technology.
Yeah, and the fact that they've already tested the flexibility and the durability.
That's really encouraging.
Yeah, for sure. But as much as I want to imagine this material being like in my next phone, I think it's also important to think about, like, are there downsides? Are there challenges?
You bring up a crucial point.
Yeah. Any new tech, especially one with this much potential, we need to look at the full picture.
We do.
Let's do that.
Yeah, let's delve into some of those potential downsides in the next part.
Okay, stay with us. We'll be right back. All right, so we're back and ready to wrap up our look at this incredible wave-absorbing material.
Ready when you are.
We've covered a ton of ground, like the potential benefits for everything from faster internet to safer self-driving cars. But like we were talking about before the break, any new tech, especially something this revolutionary, it's important to look at the whole picture, you know?
Absolutely. We need to be thinking about potential downsides and challenges.
Exactly. So, like, where do we even start?
Well, I think one of the first things to think about is manufacturing.
Okay.
Can we actually make enough of the stuff to meet the demand?
That's a good point.
Are there enough raw materials? What's the energy cost of producing it?
And what about the environmental impact?
Right, exactly. We need to make sure we can produce it sustainably and responsibly.
Yeah, because even if the material itself is amazing, if the way we make it is harmful, then it kind of defeats the purpose.
Exactly. And then there's the issue of cost.
Oh, yeah. New technologies are always expensive at first.
Almost always.
So who gets to benefit from it?
Right. And if it's too expensive, then it's not really going to be accessible to everyone.
Exactly. We've seen that happen with other technologies.
Yep.
And I think it's really important that we don't make those same mistakes again.
I agree.
So manufacturing costs, what about unintended consequences?
That's always the big question with any new technology.
Yeah, like what if there are downsides we haven't even thought of yet?
Right. So, for example, what if this material is so good at absorbing electromagnetic waves that it starts to interfere with signals that we need?
Like what?
Think about emergency responders, air traffic control, scientific research.
Oh, wow.
All those things rely on specific frequencies.
So it's like we're trying to eliminate noise pollution.
Yeah.
But we accidentally silence the symphony orchestra in the process.
A perfect analogy.
Wow. So we really need to think about how to implement this carefully.
Yeah, we need to make sure that this material is enhancing our use of the electromagnetic spectrum, not disrupting essential services.
Right, it's like walking a tightrope.
It is.
We need to maximize the benefits, but also minimize the risks.
And there's one more thing I think we need to consider.
What's
the potential for misuse?
Oh, right. Could someone use this material for, like, nefarious purposes?
Exactly. What if someone tries to block security systems or disrupt communication networks?
Okay, so it sounds like there's a lot more to think about here
Definitely.
than just the cool factor of the technology itself.
It's not just about celebrating the breakthrough.
Right.
It's about understanding the implications and making sure that this technology is used responsibly.
Okay, so for our listener out there, what's the takeaway message here?
I think it's about informed optimism, be excited about the possibilities, but also engage critically with the potential challenges.
Stay informed.
Yeah, ask questions, be part of the conversation about how this technology shapes our future.
That's a great way to put it.
This material has the potential to be truly groundbreaking, but it also raises some really important questions about sustainability, accessibility.
And responsible innovation.
Exactly.
Well, this has been a fascinating deep dive.
It has.
We've gone from the microscopic level of materials, science, to these huge implications for society as a whole.
And it all started with just one research article.
Right? A great reminder that the biggest discoveries can come from looking at things in a new way.
Absolutely.
So thanks for joining us on this exploration of the world of electromagnetic materials.
It's been a pleasure.
We hope you learned something new today. And remember to check out the full article on scitechdaily.com for more details.
And keep exploring, keep questioning, keep learning.
Until next time.